life. So that's the fine balance, more of the fine balance situation that we're talking about, is that the fine tuning, as you said, to make us happen is sort of remarkable. For example, if the electric charge, this is it. So it might not be the mass, but it might be the electric charge. The mass could be important too. Like the mass of the electron in a different universe could literally be different, but the electric charge, I think, is an interesting one. So for example, if the electric charge of the electron had only been slightly different, stars either would have been unable to burn hydrogen and helium, or else they would not have exploded. Of course, there might be other forms of intelligent life, not dreamed of even by writers of science fiction, that did not require the light of a star like the sun or the heavier chemical elements that are made in stars and are flung back into space when the stars explode. Nevertheless, it seems clear that there are relatively few ranges of values for the numbers that would allow the development of any form of intelligent life. Most sets of values would give rise to universes that, although they might be very beautiful, would contain no one able to wonder at that beauty. One can take this either as evidence of a divine purpose in creation and the choice of the laws of science, or as support for the strong anthropic principle. Onek Jotil Bishoy. Have fun, righteous. Now I'm choking. There are a number of objections that one can raise to the strong anthropic principle as an explanation of the observed state of the universe. First, in what sense can all these different universes be said to exist? I think we were talking about this the other day. I want to remind myself, but I think if the charge of the electron had been bigger, then the electromagnetic force between protons in the nucleus and electrons would have been bigger, and maybe that would have interrupted nuclear processes that make, for example, hydrogen to helium, helium to, carbon, and higher. So maybe that's what it is. Carbon has 6 protons and 6 neutrons, right? So you need so carbon is 12, right? 6 plus 6. So you need 4 helium nuclei, for example, to make carbon, right? So these are nuclear processes. The nuclei of different elements have to want to combine. There has to be enough energy, of course, but also they need to combine. But if the electromagnetic force was too high between the electron and the proton, then that could have maybe overtaken the process. I think that there was something like that, which this is why we get heavier nuclei. And if we didn't have heavier nuclei, then we wouldn't be here, right? Because the Big Bang made hydrogen and a little bit of helium, but it's really the overdensities that formed in the universe, which then gave us galaxies and stars. The stars combine helium to give us heavier elements, such as carbon, oxygen, etc. Every element heavier than helium pretty much has to be made in stars. So the nuclear processes in stars give us those heavier elements, and then when the stars die and explode, that material is spewed into the interstellar medium, which can form gas clouds and stuff like that, and those can condensate and make the next generation of stars and sometimes planets like we came to be. So it's really